We know that in order for two molecules to react, they must collide, and we know that the collision rate is dependent on the concentration of the reactants in the system. So we would expect the reaction rate to depend on the concentration of reactants. Let's take a look at this concentration dependence from an empirical or experimental point of view. Experimentally, we find that the rate is proportional to a power law in the reactant concentrations. The proportionality constant is called the rate constant or the rate coefficient. In addition, the power associated with each concentration is called the order with respect to that particular component in the reaction. Most reactions occur in a series of steps, such as the two steps shown here. Each step in the reaction is called an elementary step and is meant to show what occurs on the molecular level. The elementary steps add together to form the net reaction or the overall reaction that we observe in the laboratory. Because the elementary step shows what happens on a molecular level, we can expect that the rate law for the elementary step will follow the stoichiometry of the reaction. That is, the rate law for an elementary step can be written in terms of the concentrations raised to the stoichiometric power for the elementary step. So for instance, in this second elementary step, a B molecule must collide with a C molecule, and the rate of that collision will depend on the product of the concentrations of B and C. So the order is 1 for B and 1 for C. For an elementary step, we call these orders the molecularity of the reaction. In contrast, the rate law for the net reaction does not depend on the stoichiometric coefficients, and we must determine this experimentally. So the reaction may be any order in A and any order in C, depending on how these elementary steps combine to form the overall net reaction. So we must measure the order of reaction with respect to each of the concentrations of reactants experimentally and cannot use the stoichiometry of the net reaction to determine the order of reaction.